All right. As I'm sure you guys are already aware, 15 minutes isn't a lot of time, so we're going to rattle through this as quickly as we can, get straight to a live demo, and then hopefully we'll have some time for the questions, so please do be thinking them up. I'm Connell. I'm the CTO at Zappar. This is Simon. We're putting his PhD to good use because he's going to be my hand because I broke my finger. So thank you, Simon. We are Zappar. We make augmented reality software for mobile phones. That's our past and our history. And we talk about making bite-sized entertainment experiences. So we make little short-form experiences using AR and VR and what have you for brands. These experiences should take between 30 seconds and 5 minutes. So they should be sort of consumable and small and entertaining. So that's what we do. We call them Zaps, but they're basically bite-sized entertainment experiences. We do this for some of the world's biggest brands and licenses. So we do it for Warner Brothers and Hasbro and Disney, lots of others. And indeed, earlier this year, we announced that Zappar powers the AR function in Shazam. So Shazam have a visual component there that does AR and scanning, and that's powered by us now. Shazam has, I think, 200 million odd active monthly users, which makes Shazam, I think, one of the biggest AR platforms in the world now. We have our content creation platform called ZapWorks. So ZapWorks allows you to build these AR and VR experiences. You can publish them live into the Zappar app within just a couple of minutes, or you can embed the Zappar platform in your own app and publish for your own app in a couple of minutes. And indeed, when we and others are building content, for example, for Shazam, we use ZapWorks and, to publish content through the Shazam app. It's built up of 3 tools. One really simple one at the beginning, widgets, which is really drag and drop, all the way through to ZapWorks Studio, which is like the Black & Decker of our set. It's fully 3D, fully scriptable. It's really quite a powerful tool. But that's kind of where we've been. What we're going to announce today, or speak about today, is ZapBox, which is our mixed reality kit. So the idea with ZapBox is to take all of the types of experiences that you can do with HoloLens at its $3,000 price point, and do them with something that costs $30. So 100 times cheaper. The idea being that if wherever you could only afford one HoloLens, you can now afford 100 ZapBoxes. It was on Kickstarter last year in November. It was over, I think, 280% subscribed. We have finished manufacture of the backers' boxes, and they're going to ship this month or next month very shortly. This is the first public unveiling at AWE, and so on booth 208, we're selling them at $50, so you can come and have a go there and buy one if you wish. But let's just see it. Will we do it? Let's do it. Cool. So, yes, this is ZapBox. Well, this is the box for ZapBox. This is the ZapBox box. So inside ZapBox box is a couple of things. So we've got a Google Cardboard-style headset. So we've made some modifications to it to accommodate mixed reality. So we've cut a hole for the camera. We've got some places for straps so that you can strap it to your head. They're in there somewhere. And we've put a little bit of foam on the inside so that when it's strapped to your head, it doesn't hurt. So that's the headset. It's quite sturdy. It's just a nice Google Cardboard headset. We have a wide-angle lens adapter, so that you pop over the camera of your phone, and it gives a much wider field of view. So that instead of feeling really kind of boxed in like this, it gives you a much wider view, and it makes the computer vision that kind of powers ZapBox work a lot better. So there's that. Then also inside, we have 2 cardboard controllers I can grab. They've got little codes in the corners and a little trigger that works using like plastic. And as you'll see, we are able to track these in 6 degrees of freedom using computer vision. So it knows the position and rotation of it in 3D space. And in fact, we have 2 of them. So there's those. Then we have these things which we call point codes, which are little disks. And as we'll do in a moment, you just put them out into the space in front of you. And the first step you do with the app is you map build. So you just scan the different codes. It understands where they are. And then without having to have complex sensors like a depth sensor or lots and lots of cameras, we can understand the 3D space just using computer vision and Simon's PhD, amongst other bits. Cool. So he's laying those out now. I think we go to the phone now, don't we? So let me just see if I can get the camera feed from the phone. The phone feed. Time. Recording. There we go. Can we see that? We can. So the UI is in portrait, so it looks right for Simon. But once we get into like the next step, it will all be in landscape, so it'll look right for us too. So here's Simon. He's currently in portrait. Do you want to landscape yourself? Cool. Oh, got to hide those. Try again. Nice. So this is the ZapBox app. The first step that he's going to do is the map building. So that means, do you need to do the lens on and off as well? Cool. So the map building, which means it recognizes the different codes in the room. Just a little auto exposure. It recognizes where they all are and then works out where they are relative to each other. And then when Simon taps on the screen, it will kind of do some maths and then work out exactly where that space is, like that. Cool. So that's the first step that the user does when they start the app. So then the next thing we'll do is look at some actual content. So all this content is published using ZapWorks, our studio tool. ZapWorks works by, when you publish it, gives you a code, which Simon's going to show. That code is uniquely for your content, so you can then just go straight ahead and scan that in ZapBox. And it will download the content and then bring it into your world. So in this case, we have a little bunny popping out of the space. As you can see, Simon can move around. He can kind of look in and about. Look down the hole. There's nothing in the hole. Cool. And he can pop into VR mode, which when you're wearing the headset, obviously that gives you the complete experience. So there's some really cool things we do here to make this work properly. So for example, the camera is rendered in stereo, but we don't have two cameras on a normal phone, so how can we render it in stereo? Well, what we do is we use the map. So we know that the map is going to be on a flat surface, so we assume that the camera is kind of on that map and then kind of goes up and does something in the distance that we don't really care about because it's so far away that our eyes can't tell it apart. And so as you can see here, Simon's put his hand on the table. He can point at a bit of virtual content, and even though the virtual content is rendered at distance, his hand seems to kind of correspond to the right place. It's a bit of a subtle point, but it makes a huge difference when you're actually viewing it in, with the headset on. Cool. We look at another bit of content. So what's this one? OK, this is a joke, this content. It's what we're going to do is we've got a sparkler here on one of the controllers, which we can track in 3 off, 6 off. And we're going to like start it, and then it's going to blow our minds. So this next bit of content is some work we did with an architecture firm in London called HLM. They built this building. I think it's in Canary Wharf in London. And this is just a way of visualizing that model. And so in this case, we've got some UI elements, I suppose, that you interact with using the controller. So they're kind of physically based in space. So you go along and you press the buttons like that. So just interesting kind of questions about how you expose interaction in an MR space. And we think the controllers, along with the triggers on the controllers, make for a really interesting way of being able to interact. And of course, in fact, I think the next bit of content maybe makes the point I'm about to make, so I'll wait. OK, this is a solar system. So this is just kind of to demonstrate some educational uses. One of the things that it being $30 means is that instead of having one HoloLens for your entire school, you can have 100 ZapBoxes, so potentially every class has a ZapBox. So the accessibility afforded by its price makes for some really interesting use cases. Another thing to mention here is, and in fact, it was mentioned in our talk title, but because we've only got 15 minutes, we can't really do it, is collaborative experiences. So the idea, a system that we're building into ZapBox means that I can have an experience, I can tell Simon to have the experience, and he might be in London and I might be here, and I give him a link, and then we have an experience where he uses his map, I use my map, but we collaborate on the same piece of content or on the same experience. And the ZapWorks system behind the scenes makes sure all that data is synchronized between the two people having it, so that I can say, I think this planet is interesting, and tap it, and then for Simon, he will see the same planet. So this one is a xylophone. The cool thing about the xylophone, and the point that I was about to make earlier but didn't resolve, is we can track both the controllers at the same time. So if I come round and pretend to be Simon's other hand, we've got two controllers here. And the audio isn't linked up through the HDMI cable, but it goes like doom, doom. Cool. Nice. All right. Yeah, so I don't think there's any more bits of content to show at the moment. As I say, ZapBox is selling it on our stand, and you can come and see it and try it for $50. Yeah, there we go. We've got Wycliffe. Nice. Yeah, it's not very 3D. Alpha video. Cool. So yeah, please do come down and see us at 208. Shipping to the Kickstarter backers this month. So you guys, it's a kind of treat to be able to get access to it so much earlier. Cool. Hopefully we've left a little bit of time, if we can, for a question. One question. We're allowed one question. Cool. Anybody with one question? The most excited hand will get it. Go on then.
Thank you for that. With the collaboration aspect,
We
all have one of these ZapBoxes on our heads. Can we experience the same thing in the same place and interact, or how does that work?
Yeah, so the question is, with the collaboration element, is it possible for us to all collaborate in the same physical space on the same piece of virtual or mixed reality content? Yes, absolutely. There's a couple of elements to that we've designed to cater for that scenario. So first of all, every box, there's actually 4 flavors of box, A, B, C, and D, and they all have different codes. So each point code is kind of unique. There's 500 different possible ones. Each box has 10. A, B, C, and D each have a different set of 10. So if you've got all 4 sets, you can make a much bigger space with your 40 codes. The other thing is that the controllers, they all have little, I don't know the name of that shape at the top, with all of the different codes on them. Left and right have different sets of codes, but left and right in A, B, C, and D all have different sets of codes. So what that means is if I'm having an experience in the same room as Simon, we've both got our own headsets on, his set isn't going to think that my controller is his controller. So we can have that experience and we can collaborate. And then from the software's point of view, it will assume that we could be anywhere. We don't have to be in the same place. We'll happen to be using the same map, but the same collaboration framework inside ZapWorks in the app will mean that the data is synchronized between the two of us. Cool. All right. I think that might be our time. Thank you.